Hello and welcome back to Mars. I'm Mick. We're playing Stationeers. Now we're in an experimental world here. Take a break from our normally scheduled program because today we're going to build an airlock. Now something I haven't done mainly because I couldn't get these doors to work. I could never figure them out because whenever I look at it, they never actually do anything. Look at them there, they open, they close. I cannot see anything what's happening with the button at all. But I did see Elmo managed to make an airlock there and he explained how they worked. So now I can make an airlock. I do know how. So that's what we're going to do. Now the trick with the airlocks here, the doors, we had to put them into a logic mode. So if we go to the doors, any old door will do. We see they have operate in normal mode, just works with the button, and a logic mode where it doesn't work with the button. It just is a dumb device there. But I could never figure out how to read the button because that was a tricky bit. But anyway, we shall switch it over to logic mode. So I shall need to alias the door to D0, and I shall just save to the door mode 1. I spelled S wrong. Confirm. And I spelled mode wrong. Export now. So if I switch it on and actually connect it, so we want the glass door switch here on. Now that should be, says there, yeah, if I point to the little tooltip says it's currently in logic mode. So if I push the button, nada happens. So now, the thing of this is, whenever I looked at this one there, I tried to find out here, if I push the button, I can see that none of the settings actually change. So how do you read that button there? Well, it's actually the setting you've got to read. Even though it's doing nothing, it's because the door is open that it wants to, the setting changes to whatever it should be. So open is 1. When I push the button, the setting should say 0 to say close the door. But because it's already on 0, I could never see anything happen, and I found that really, really confusing. So if I, get rid of you. If I take that off, I'll have to force the door closed. Yeah. And looking back up now. Now if I look at it, open is 0 and setting is 0. But if I push the button, the setting should change to 1. Boop, there it goes. That is to tell us that the open wants to go to 1. So all I do to make this operate as a normal door is just read the setting and copy it to the open, and that should have it operating as a normal door again. So we shall yield load into R0 from the door the setting, and we shall save into the door open R0 and jump to the start. If I export that, now if we look at it there, we see the setting 1, it's open as 1. If I push the button, the settings should go to 0 and write that to open, and there we go. And back the other way, of course. Open and open. Right, so that is how the doors work. I never figured that out, so yeah, there we go. I can do it now. So now we can actually build an airlock. So the trick with this is though, when the door opens, it does not change the setting. So if I use something else to open that door, the setting doesn't change either. So if you trigger the door by some other mechanism, you also have to manually change the setting or it's not going to work. So right, but that is what we need to do. So that will be basically what we use for the airlock. So we should be reading the setting and writing it there. Now this one, first up, we'll probably write the most simple of, well, it's not really an airlock. We'll build a simple one, which is basically a bulkhead sealer. So what we'll be doing is just having a system like this, which just won't let you open both doors at the same time. So if you have a bulkhead in your base, you don't want to go through an airlock. Something there we can just go in, push a button, close that door, then open this one, and we just run through without having to run through with a decompression cycle. So that'll be the simplest of things we've got there. So for that one, we will say that we are inside here, and I don't have a labeler. Right, labeler. So you are the outer door, and you are the inner door. And that's all we need, because we don't have any vents or anything else. We're not running a decompression, so we don't need a sensor or anything like that. All you want to do is close one door, open the other door. So I shall need, let's see, inner door, D0, and the outer door, D1. Right, so now we'll have to set up where it's at the moment. So one of them will have to close, one will have to open. So this one will have to be a script that won't run all the way through every time. It'll have to go to a certain loop within the script, either to be open inside or open outside, and then go back to the start, and it'll just switch between whatever it's going to be. So we shall set up, what do we call it, open outer, and we shall have an open inner. Yes, my old programming naming compulsive disorder there. Right, so when we're opening the outer one, you shall want to save the outer door. It's open, so 1 to open, and save the outer door setting. So we'll have to set the setting as well. We can save the inner door, open is not open, and save inner door setting 0. Right, so that sets us up for where it is. So when it's open on the inside, of course, it'll be the other way around. So quick copy and paste, copy and paste. So the other way around will be 0, 0, 1, 1. Right, so that'll be one setting one. Now, when it's sitting here, we don't want it to just run all the way through. We want it to come here and then wait till the button has been pressed, then we can progress in the code. So we shall have a wait outer. Now all we're going to do here is yield, and we shall load into R0 from the outer door. Now we don't know which button's been pressed, so we'll have to look at them both. If I get it right, outer door setting, and load into R1 the inner door setting. Right, now you can just check one of them if you want. You could just check the door that's closed, because chances are if one door is closed, you're going to run in, probably press the door that's closed, or if it's the other way around, you're going to walk up to it and press the door that's closed. Well, you don't have much option there. So that's how you could do it, that one there. But if you do want to switch it around for any reason, push the outside one, I want it to still work. So what we're going to do is we're going to check them both. Now if I pressed one of them, it'll change. Currently they're both different. If I push that one, it'll change to 0 and they'll both be equal. If I push this one, it'll change to 1 and they'll both be equal. So we're just going to check and see if they're equal. Well, actually, we're going to check and see if they're not equal. If they're not equal, nothing's been done. We can jump back to here. So we shall branch not equal. So if R0 and R1 are not equal, no buttons have been pushed, wait outer. So we'll just go back and just keep doing this until a button's been pressed. Once a button has been pressed, we can just go to the open inner one. So then flick the doors around, and there we go. And then of course we'll have to wait inner. Wait inner, and we shall do the same thing there. Copy, paste, copy, paste, copy, paste. Of course this will be exactly the same because all we're doing is comparing them. They'll be around the other way, but they'll still either be equal or not. And that shall be an inner this time. Of course, once it gets to the end, once a button has been pressed, we're just going to go straight back to the start. So jump, open, outer, boom. If we export that, we get an error because nothing's been done. And here's my screwdriver. No, it's not a screwdriver. So now I need the inner door and the outer door. Yep. That resets you. Right, one door's open, one door's closed. Push the button. That didn't work. Why didn't you work? I didn't set them into the right mode, you fool. Okay, right. Now we shall save. Outer door, mode 1. Save, inner door, mode 1. Let's try that one again. Right, now they are in logic mode. Push the button and they both change. I should be able to push the other one and they change again. If I push either one, it doesn't matter. It still does its thing. Now they do both open and close at the same time, so you will get a bit of transfer of atmosphere. So we may not want that. So what we can do is close the door before we open the other one. So if we open as 1, so 0 is closed. So what we shall do is take you up to there, you up to there, and then I shall yield, wait for the doors to close. That is the close, yield, confirm, export. Now, maybe a double yield. Wait a bit longer. Wait 2 ticks. Export. That one's looking better. That door closes, this one opens. I want to go through, that one closes, then this one opens. So I should be able to go through one room to the other without having to worry about an explosive decompression. So if I do have a fire or something in this room, I should be able to sneak through to the other one very quickly without having to let the fire spread, or pollutants or whatever's in there. We'll allow 1 cell worth of stuff to go through, but yeah, if I have an explosion or something in here, it does decompress the entire base. My bulkhead here is always sealed, so I'm not losing everything. So that's the most basic one you could possibly have. So let's put a venting cycle on it now. You are the outer door, you are the outer vent, the inner vent, and the inner door. Right, and I do have a diode slide there, so we can actually look at the pressure if we want. Of course, a gas sensor, so we know what's actually going on in here, and inner and outer vents. Right, so I can switch you on to the an error. There we go. So I need the inner door. Inner door. I shall need the outer door. There it is. Now I shall need the inner vent. I shall need the outer vent, and I shall need the sensor. Right. Reset you, switch you on. Now it should be behaving the same as the other one because we haven't changed the code. Right. Now we'll need a couple more cycles than just to open outer, open inner. We'll have to go through 6 phases on this one there. Because after the open the outer, I shall want to vent the outer. And then I shall want to pressurize the inner. Then I can open the inner. Then before I go back to start again, I shall have to vent the inner and pressurize the outer. And then I can open the outer. Right, now the things we want to do. Now before we open the outer, we probably want to switch our vent, make sure our vents are switched off. So alias the inner vent D2 and alias the outer vent D3 and the sensor D4. Oops, spelled D wrong. I'm doing well today. In my defence, those D and F are right beside each other. I call that a coordination problem, not a spelling problem. Yeah, that makes it so much better. Now, what we've got to do is vent the outer. So we shall need to close the doors. Right. So we're venting, we've got the inner door open, we want to vent the outer. So what we're going to have to do is actually vent that out here. So I shall need to copy you, and I shall want the yields in there because we've got to wait for the door to close. Right. Push the button, we close the door, wait for the door to close, save, we want to vent the outside, so outer vent, mode 1 to set it out, and save outer vent on 1. So that should take it down, switch it on, and wait for the so it'll evacuate the area. Now I shall now want to read the sensor, and wait till the sensor comes down to 0. Right. So I've actually done this bit here has already been done, so I can actually probably just say after I've done that one here. I might actually just pull my hold point out, take you down to here, so I can use that for my loop now while I wait. So now I shall just have to yield here, load into R0 from the sensor, the pressure. And I shall now branch greater than 0, greater than 0. So if the pressure is not 0, if the pressure 0 is not 0, skip back up to vent outer. So just keep doing that loop until the vent outer, until the pressure reaches 0. Right. Once that's done, you can pressurize the inner. Let's not worry about that one just yet. We shall just do an explosive decompression on that one there. Now, our door is already closed, so I can probably get rid of those ones. Although it's probably good to have them there anyway. Now, if the first time you use the thing, it might be a good idea to keep them in there. So I might just keep them in there. It doesn't hurt. Might use up some line of the code, but who really cares? Right, so I may want to copy you down to there. Copy you down to there, just to make sure they're closed. Now, we shall also want to make sure our vents are switched off. So I shall save to inner vent on 0, save to outer vent on 0. Right, switch the vents off, make sure the outer door is closed and the inner door can then open. Right, so let's go through it again in a less nonsense way. So we are set up here. We want to wait for the button to get pressed. When it has been pressed, we close the door, wait for it to close, switch on the vent, wait for it to go to 0, and then we can open the inner door. Simples, right? And then we have to go back the other way. So once again, we wait for the button to be pressed. We shall need to close the inner door, which is you. Open shall go to 0, setting shall go to 0. We shall wait for it to close. Then we had to switch on the vent. So we shall save to in event mode 1, just to evacuate it. Save in event on 1, switch on the vent. So now we've just got to wait for the pressure to get to 0 again. So we shall wait a little bit. Load into R0 from the sensor the pressure and branch not equal to 0 to vent inner. Right, so once the inner is vented, we're going to skip the repressurization for the moment and we can just go back to the open outer, which is back up the top there. Now for this one here, as we did before, we can actually skip the yield now because we've put it in a different spot. Just got to check that the doors are closed and check that the vents are switched off. Inner vent on 0, save outer vent on 0. Confirm. I've made a mistake in all of that, not as yet. Oh wow, it's worked, okay. So, if I push the button, I should be able to push either one of them. It closes, vents the room to 0. I'm on Mars, so there's not much of an atmosphere here, so it doesn't take long. And then it opens the other side. Oh, simples, okay. So that's that. That is working as a venting airlock. So now we want to put in our repressurization cycle. Right, So after it's vented it, it's got to 0. We now want to switch off the outside, the outer vent. So save vent, save outer vent. So we're going to switch off the outer vent. Simples. We shall want to repressurize. So we shall save in event mode 0 and save in event on 1. And once again, we're just going to wait until we have achieved the required pressure. So we shall once again put in a yield, load into R0 from the sensor pressure, and we shall branch less than, so if the pressure is less than what we want, so if R0 is less than, we'll just go to say 10, go back to pressurize the inner. Right, once it's reached pressure, we can open the inner door and off we go again. So I shall want to repeat that for our pressurize going back the other way as well. Okay, and then we can open the outer door. The outer door, make sure both the vents are off and we're good. Right. Okay, so if I push the button, it's pressurizing the inner now. And it's on low pressure here on Mars, so that is not working real quick. Awesome. That has also exposed a little bit of a trick there, because when I plugged it in, it automatically switched the vent, the airlock to the other side. So that would be a bit of a problem if there is we're on somewhere like Venus and you suddenly close an oxygenated atmosphere and open to a hydrogen one. So we'll put a little bit of code at the front to actually check which way it is facing before it does that. So what I want to do is before it opens the outer, we shall have a look at the outer door and make sure that one is actually open. Right, so she'll load. So this will be outside the main loop of the program. So we shall load into R0, outer door, open, and we shall say, oh, it finally got there. We shall say load, branch equal to 0. 0. So if the outer door is open, carry on. If it's equal to 0, we go to the open inner. Right. So we check the outer door. If the outer door is not open, the inner one should. So we just jump down to the open inner and start the program there. It goes in a loop, so it doesn't really matter. If the outer door is not open, or is open, we should just continue on to the open outer. Right. So if I export that, see, it didn't switch the airlock that time, so we're good. Now, you can go into here. It vents the inner, and it's going to try and vent the outer, which takes a very long time. One, okay, yeah, that takes a while. But there are ways around that. Yeah. Problem solved. Still waiting. Right, so before we do that one there, I shall put on a little pressure indicator in there as well. So all we have to do with that one is when we're venting, where are we? We are venting the outer. We load the pressure sensor. Now I shall need to write to the diode, which is that one a value out of 1 or a value out of 100? I can't remember. Well, I guess we'll soon find out. So save to the diode setting 0. So I need to put the diode in there, don't I? Diode D5. Right. So I might even put in a little function for it. No, I won't. So venting it, all we need to do is we'll define a pressure setting to make that easier. Oops. Fine. I suppose we've got to set an internal and external pressure, don't we? Pressure. Pressure inner and define pressure. Just like the advanced airlocks will do that. So the pressure inner we shall put to 100 and pressure outer we shall put to 1. Right. So what we shall do here, so now we have that there, we can have a different inner and outer pressures. So let's just get rid of that for a moment. And we can say, let's actually try pressurizing the room. That might be a good idea. Right, so let's let the room pressurize a bit. And let's see how we go. Now, while that is happening, you have a pressure inner of 100. So we want to vent the outer to 0, pressurize the inner. So we're just going to check if it's less than the value we've defined at the top, the inner pressure. When we're venting the inner, we vent it to 0, pressurize the outer to pressure outer. Right. So that will now take it down to the separate settings there. Now our diode, now when it is venting, we're going to use our pressure inner as our, well, it'll be our base score for what we're doing there. Now we are venting, I think I will put in a separate function for it. So we shall have, set the diode. So now R0 will be the pressure, which we've loaded, and then set the diode. So we shall want to divide. So R1 will equal the current pressure divided by the pressure inner. So whatever value we've set, whatever fraction of that is what we're going to have. And save to the diode. Diode setting R1 and jump back to wherever we were. So now I can just call that from wherever we want. So we are setting, we are venting the outer. So now we're reading it. We shall put set diode, or jump to set diode, and link to set diode. So that should set the diode. Come down, and then we are, that's where we're venting out as well. Vent outer. Vent outer is up there as well. So just after the yield, I shall put in set diode. We are waiting for it. Close the doors, vent the inner, set the diode, pressurize the outer, set the diode. That should be what we need. Now, I haven't got my diode on there, so I shall need to do that. Diode slide, there we go. Get rid of them. Export that. Okay, we're almost up to pressure in here. Wow, that's very slow. Damn, that's a slow airlock. Okay, 76 kilopascals and extraordinarily slow in there. Damn. Oh no, now we're speeding up. There we go, and we're open. Well, I think I might put longer pipes on those things just to speed it up. Right, that should speed it up a bit. Now, I should be able to press that button. It vents out very, very quickly. Repressurize to 1 kilopascal, probably still take a little while. Once again, it's just a small ventilation system outside. Very good. Open on the outside. Push the button. See, there we go. Now it's a lot quicker. And we're open on the inside. We're a bit short on pressure, but anyway. Now, one other thing I want to put on this airlock is an abort. So if I accidentally walk into my airlock without my spacesuit on and push the button, I want to be able to quickly change my mind. Now we can do that by checking the button during the depressurization cycle. So if we are in here, where's my set diode gone red? You silly machine. Right, we go into here and we sort of say, while we are venting the outer, we could probably put an abort on the repressurization cycle as well, if we're in a hurry. So we're venting the outer, loading the sensor for the pressure. We can also load, so we have just closed the outer door. So if we want to abort, we want to open the outer door. Right, so I'll turn around, I'll push the button on the outer door. So load into R0 from the outer door setting, and I shall, now we've put the setting to 0, so if it's not 0, we've pressed this button and we want to get out again. So branch not equal to 0. So if the button has been pressed, we should just abort it and just immediately go back to open outer. Open outer. Right, that's it. So we don't worry about repressurizing. It's emergency. Just well, we've only partially depressurized, so we should be able to get back out again. And we can do the same on the vent inner. I mean, we can do it on our repressurization as well, I guess. If we don't want to wait for the pressurization to happen, we want an explosive decompression. We're just going to check the inner door. So I'll load into R0 inner door setting. Now it should be closed, so it should be 0. So branch branch not equal to 0. So if the button has been pressed, we just skip this sequence and go to open inner. At which point it'll skip the repressurization and just jump straight down to here. Right, and we can do the same on the other side. How much code do I have left? I've still got plenty of code left. Right, so venting the inner, we shall load into R0 inner door setting. Okay, branch equal branch not equal to 0. The button has been pressed. We want to abort and go back to open inner. Yep. Right. And we're pressurizing the outer. We shall load into R0 from the outer door setting. Branch not equal to 0. If the button has been pressed, skip the repressurization and just go to open outer. Cool. There's that stuffed up. Maybe not. Okay, so if we press yes, we want to do it. Nope, change my mind. I can't push that one. I've got to push that one. Change my mind. We're back to the inner. So if I hop in here without my spacesuit, let me back in. We're fine. Right. And of course, if we do want to go out, we can skip the repressurization cycle. Oh, that wasn't quick enough. Anyway, we come in. Why did that skip the repressurization cycle? Did I get that wrong? Oh. Okay, what have I done? You're closed. Oh, so I haven't set you back to 0. I see, right. Okay, so I know what's gone wrong now. I have to set the buttons. Because when we come here, we close the outer door, but we could have pressed either button. So I have to set both buttons. So save inner door, setting to 0. Right, tricky. So 0, save, oops, outer door, setting to 0. Right, says we can push either button. Export that. Now, you're both set to 0 and 0. If I push that button, it stays at 0. Right. So now, I should be able to skip my repressurization by pushing that. Nice. And same on the way in, that gets set back to 0. And I should be able to skip my repressurization if I'm quick enough to push that one. Right. And that diode is now not updating. Why not? Alright, I stuffed something up again. Oh, because I've got the right. We're going to load the pressure, then set the diode. That might be a better way to do it. Load the pressure, set the diode. Where are we? Load the pressure, set the diode. Load the pressure, set the diode. I should have some more of them in here. Load the pressure, set the diode. Load the pressure and set the diode. Right, that's the dangers of reusing your variables and not being careful. Right, there we go. Kind of upside down, it's a little bit irritating. There we go, our airlock is working as it's meant to be. So we've got our abort, we've got a little pressure sensor, we've got a fully functioning, full automatic airlock. Now, in places like Mars, we might not want a two-sided one there, or the Moon. We may just want a one-sided one with just a vent on the inside. We could do the same thing with the same code. Export U and import that into there. Now we can do the same sort of thing here, but once again, we've just got to skip the repressurization cycle on the outside. So I should need an outer door, inner door. Well, it's only going to be one vent, isn't it? But inner vent and diode will be fine. Now, of course, we switch this one on, we'll get an error because we don't have an outer vent. So that is an inner door, outer door, inner vent, outer vent we don't have, gas sensor, and a diode. We're good. Right, now all we have to do is skip the repressurization. Let's just say we don't have an outer vent, so if I get rid of that, edit that, anything that says outer vent should be red now, so I can easily find it all. So we don't need to open outer, wait for the button to be pressed. Now the outer vent, we don't need to switch that. we're venting the outside there. We don't need to do that, so I can just take that entire thing out. And then we just switch on the inner vent, pressurize the inner. Don't need you. Once again, on the way out, we don't need to pressurize the outer. We depressurize the inner. We can't switch the outer vent on, and we don't need to pressurize the outer. So we can just switch that off completely. And jump back to the top. Right. I should be able to export that. Switch you on. You're working. Should vent the inner. And immediately open the outer. Easy. And repressurize on the inner. Right, so almost exactly the same code, we've just taken a few bits out of it. We've just taken out 2 of the 6 stages there. We've taken out the pressurize the outside and the depressurize the outside. Right, so that is that one there. Now, there is another one there, a couple of extra little bits that I would like to do with it. Now, I do have, the way I normally build my bases is I will import that code, is I'll build it a section at a time. So what I do is I'll build a room, pressurize it, get it good, put it in a temporary airlock and build the next stage out there and wait till it comes good. So I would like an airlock which can then find out what's on the other side of the wall and then just become a pass-through airlock when it's safe to do so. That one's not safe to do so at the moment, obviously. So I shall want to have, in this case, I'll put an indicator light on there, it's just an LED. It'll tell me whether or not the other side is safe. So we need to have a sensor on the inside and the outside to tell us, of course, whether or not it's safe. So I shall need a sensor. So a sensor, gas sensor on the outside. Oh, that's the inside, and one on the outside. Right, and cable. Right. There we go. Right, so now I have an outer and inner ones of the sensors. And an airlock sensor. Right, now I don't have any spare pins on my chip. So to read those ones, I'm just going to batch read all 3 and take the average. And then compare that average to the inside one. So if those 3 all add up to the same as this one here, then it is the same on both sides of the airlock. If it's not the same, then it's not the same. Bear in mind, whatever pressure we have here, is that these 2 should be the same, and that one will be different. So if we're happy to have a 10% difference in pressure or whatever and say that's near enough, we have to make sure that we set our difference to be about 3%, because as I say, these 2 will be the same and that one will be different. So it's 1 out of 3. So that one could be 10% difference and the average will only be about 3% different. That's maths. Trust me. All right. So we shall still want the same cycling code. But all we have to do is once we get once we start the check on it there, the venting, we just need to decide whether or not we want to vent. So we shall, we're not going to set a diode because we don't have the diode anymore, we've got an LED. And we shall use that one to tell us whether or not it's the same on both sides. So I shall do that and edit it, and I shall put this one here just to call check mode. Rightio, so that'll change the name of that. So if I confirm that and edit it again, everywhere I've got it should now be red. Make it easier to find. And I shall also alias the airlock mode to 10, why not? Okay, so we called it check mode. Right, so when the door is open and we are waiting for a button press, we shall just say check the mode. So it'll check while the airlock's open one side and it's waiting for a button to be pressed, it'll just pop down and do the check mode routine to see if it's safe to bypass the repressurization cycle. So we shall not want to do U. We shall not want to use U. While we've got the inner side open and we are waiting for a button press, we shall just check the mode again. All right, and we're not worried about the diode. Okay, now I shall also need the sensor batch, so I shall need sensor, gas sensor, I shall need U so I can batch read them. Right, so I shall need to define sensor to U. Right. Now I'll have to test another code there because that is a command that I've not used before, so that'll always be fun. Right, so I want to load batch. I should just load into R0 from the sensor, which is the inside sensor of the airlock. The pressure, and I shall load batch into R1 from all of the sensors. The pressure average. Right, now I shall say set approximately, so set R0 if R0 and R1 are approximately the same. What am I doing? I'm saying airlock mode. Set airlock mode if R0 and R1 are approximately the same, and we give them, I think it's just a percentage we give them. So if we, yes, set set approximate. So off these, so set a register, airlock mode, if R1 or R0 by constant. Now I believe that's a percentage, whether it's at 100 or 0, I'm not sure. So I've not used this one before, and while this explanation might mean something to someone, no. So that's our constant that we apply a maximum to. So it's just a constant. It's not a percentage, it's a constant. So let's just act like we know what we're doing and go with that one. So we say it's got to be within, say, 10% of it. So let's say it's an average out of 3, so we shall say int 03, so 3%. I've put in the wrong one. Try there. 3% of that one, and get rid of that one there. Now, I can say save LED on airlock mode. Right. I haven't switched it on. Right, so glass doors, I better name them all and set it up, hadn't I? Outer vent sensor, which is the airlock sensor, and the LED, which is the yeah, I got two of them. Which is the mode one in there, why not? There we go, mode LED. Right, that should be enough. Reset you, switch you on. Yeah, it switches itself off to say that it is not right. So they are not equal. So now what we want to do is say when they're not equal, we want to be able to say, I'll say if they are equal, so door, the button is pressed, we vent outer, we want to be able to say branch equal airlock mode. If airlock mode is 1, they are both the same. We can just skip straight to open inner. Yep, and after we wait for the button to be pressed, we close the door. Now we switch the vent on. Okay, let's just take you up to here then. Right, before we switch the vent on, we do that check. If it's okay to open the door, let's just skip straight down to there. Once again down here, we shall do the same check. We'll jump to the outer. Right, export you. So now if I push the button, it should go through its cycle. Yep, slow cycle. Through we go. We're good. Same inside. So now I'll have to wall that up and get it the same pressure. Simples. Right, so a wall. I should pull that out. Ah, okay, maybe not. Well, at least we found my screwdriver. Right, so now, if I pull that out, I shouldn't be venting straight out into space. And once both sides are the same, that light should come on. Anytime soon. As I said, if I open both of them up, there we go. Right, so now both sides are near enough to being the same, so it's happy. If I come in here now, it should just bypass it. Now I can get my screwdriver back. Nice. That make it unhappy? Nope. So now everything's fine. I can have my base, and I do something silly in here. It says, okay, we're not happy now. Something's happened on that side. Now you're back to being an airlock. Nice. So now when I'm building my base, I can just put in one of these airlocks. As the next room pressurizes and does its thing, once it's ready, it'll just tell me and it'll open up for me. Nice. That's what I wanted. Yeah, you probably pretty it up a bit. Maybe put that at a coloured light. I could probably have that go red while the airlock cycles. Maybe have it going yellow when it's both sides are not the same. Have it go green when both sides are the same. Let's see what we can do. Right, and we've had a bit of a coating, bit of a clean up. Thick it. Yellow light now. Right, so what I have done is just at the end there, instead of switching the LED on and off, I've just got it to set the colour. It's got a little equation, you subtract 3 and add 5, and it'll either go green or yellow depending on what the mode is. I have changed it to red. When the airlock cycles, I'll just change the colour to 4, which is red. So as soon as you switch the vents on, it changes to 4. And as soon as the doors open, it goes back down to the check mode, which sets it back to its normal colour again. Now, as I had a few lines of code left, I've still got a few lines of code left, I've also checked the pressure, the temperature, the volatiles, and the pollutant. So all of them have to be within 10%, well 3% on this one there because there's 3 sensors, and that allows a 10% error on the last, on one of the 3. So it checks for all of them. If all of them are the same, it will turn the light green and I'll allow you to bypass it. So at the moment, push it through, boop, we get a red light while it's cycling. And yellow light goes back to yellow. As I say, if we once again equalise the rooms, I have repaired the wall. It should go green when they're equal, or near enough to, within 10%. Anytime soon. There we go, green light. Right. And we are at 99 kilopascals, that is within 10%. So now, closes that one, opens that one, I can just bypass through without having to go through the slow-ass compression cycle. And once again, if this wall gets compromised, any pollutants get released or any volatiles get released, it'll go back to an airlock, so keep all of that nasty crap out of there. Nice. So there is my custom airlock. And I shall be using that in my mountain base. Yeah, it's a bit of a long one there, so I didn't want to be doing that in a playthrough. So there you go. That is custom airlocks. Yeah, so there's plenty of different ways you can configure them. Just do whatever floats your boat on them. Let's say the same basic cycle that we have for this one here is used in all of them. Just add bits or remove bits as you need them. So you can have it for just a straight through, or a single vent, or a double vent, or a automatic bypass, whatever works for you. But there you go, all done. Nice. I have finally made a custom airlock. Bit weird without having the console in here, but we'll get used to it. Radio. But that's about all we got time for. So until next time, happy building. See ya.